Good morning, students. Our today's topic in the subject of Mechanics 1 in class A levels is second law of motion of the Newton. So concentrate yourself. We are going to start. This law defines the relationship between the force, mass, and acceleration. It seems reasonable to accept that for a body, for a particular mass, the bigger the force is, the bigger the acceleration will be. Second point, the larger the mass of the body, the larger will be the force needed to produce a particular acceleration. So this is vice versa. So bigger the force, bigger will be the acceleration, or in other words, if bigger the acceleration, bigger force is required. Okay, experimental evidence verifies that the force F is proportional both to acceleration A and to the mass m, that is, F is directly proportional to ma. And when we will convert this proportionality sign into equality sign, we have to put a constant k with the right side value. So F is equal to k ma, where k is a constant. Now, if m is equal to 1 and a is equal to 1, then F is equal to k, because when you will put 1 over here, so 1 will be multiplied by k, so F will be equal to k. So the amount of the force needed to give a mass of 1 kg and acceleration of 1 meter per second square is given by k. If this amount of the force is chosen as the unit of the force, we have k is equal to 1 and F is equal to ma. So this is the formula that will be used in numerical questions. The unit of the force is called the Newton and is defined as the amount of the force that gives 1 kg and acceleration of 1 meter per second square. We know that acceleration and force are both vector quantities and that mass is scalar. So mass is scalar, but force and acceleration are vector quantities. Therefore, the equation F is equal to ma shows that the direction of the acceleration is the same as the direction of the force that produces it. So, in which direction the force is applying, the acceleration will be produced in the same direction. When more than one forces act on the body, F represented the resultant force. If the force is constant, the acceleration is also constant, and conversely, if the force varies, so does the acceleration varies. So this is very simple thing. If force is constant, uniform, then the acceleration produced will be constant. But if force varies, sometimes greater, sometimes smaller, so the acceleration will also varies. Okay, if the acceleration is 0, the resultant force is 0. In other words, Newton's first law follows from the second. To sum up, the resultant force acting on a body of a constant mass is equal to the mass of the body multiplied by its acceleration. So F is equal to m. Mass will be in kg when we will solve the questions, and acceleration will be in meter per second square, and force will be taken in newtons. The resultant force and the acceleration are in the same direction. So this is very important point. Force and acceleration will be in the same direction. And now we are going to do some questions that will make your concepts more clear. What kind of the questions come in the paper? So concentrate yourself. First question is, a force of 12 Newton acts on a body of mass 5 kg. Find the acceleration of the body. So force is 12 Newton and mass is 5 kg. Acceleration is required. So F is equal to ma is the formula that will be used. So look now, 12 Newton will be put in place of the F and mass is 5 kg. So 5 will be placed in place of the m. So 12 is equal to 5a. So 5 will come into the denominator of the 12 and you will solve it on the calculator. So a will be equal to 2.4 and the unit of the acceleration is meter per second square. So 2.4 meter per second square is the answer. In question number 2, A set of the forces act on a mass of 3 kg and give it an acceleration of 11.4 meter per second square. Find the magnitude of the resultant of the forces. So look now, here is M, that is 3 kg, and A is 11.4 meter per second square. F is equal to ma will be the formula that will be used, and M and A's values will be put into the formula. So look now, M is 3 and A is 11.4. You should put the units as well. M is 3 kg and A is 11.4 meter per second square. The formula will be used, F is equal to ma. Now you will put these values of M and A in place of M and A. So F will be equal to 3 multiplied by 11.4. You will solve it on the calculator. 34.2 will be the answer. And because this is force, so Newton is the unit. So this is the answer. Look at the question number 3. The diagram shows the forces that act on a particle of mass 5 kg. So here is the diagram, causing it to move vertically downward with an acceleration of a meter per second square. Find the values of P and A. So, okay, causing it downward vertically with an acceleration. So it means horizontal forces should be equal, because it is given that there will be an vertical acceleration. So it means P will be equal to 7 Newton. So look now, P is equal to 7 Newton. So one thing is done. Now second thing is that is required is A. So look now, vertical and upward and downward forces. So 3 Newton force will be balanced with 3 Newton force, and now the resultant force will be 3 Newton downward. So that is the force, and mass is given 5 kg. So force is 3 Newton, mass is 5 kg. Now you will use the formula, F is equal to ma, and F is 3 Newton and M is 5 kg and A is required. So this 5 will come to the denominator of the 3. So you will solve it on the calculator and you will get the answer, and the unit will be meter per second square. Here is another question. So concentrate. A force F newtons acts on a particle of mass 3 kg. A part is, if the particle accelerates uniformly from 2 meter per second to 8 meter per second in 2 seconds, find the value of F. So in this part, first we will find the acceleration. So look now, this will be the initial velocity. So U is 2. This will be the final velocity. V is 8 and 2 seconds. So time is 2 seconds. And first we will find A. So the equation will be used, V is equal to U plus 80. Now these values will be put here, and from here you can find 8 is equal to 2 plus 2A. So these three values will be put in the formula, and from here A will be find out, that will be A is equal to 3. Okay, now the requirement is find the value of the F, and now the formula will be used, F is equal to ma. So mass is 3 kg, so 3 will be placed in place of M, and A is 3, so 3 will be placed in place of A as well. So 3 3s are 9, so because this is force, so 9 Newton is the answer. Okay, in the second part, if you can see, if F is equal to 6, find the displacement of the particle for seconds after starting from rest. So after starting from rest, it means the body will be initially in rest position. So U will be 0. So look now, here is the data. So U is 0. Force is given 6 Newton and mass is 3 kg. So first again we will find A. So F is equal to ma. F is 6 Newton. So this is 6. M is 3 Newton. And from here A will be find out, that is 2. Okay, now we have A. Initial velocity is 0. Time is 4 seconds. So initial velocity is 0, A is 2, and time is 4 seconds. And the requirement is S. that is the displacement, that is called distance. So look now, the equation will be used. S is equal to ut plus half at square. And now put these values into the formula. So here are values placed in the formula, and solving it will give you the answer, because this is displacement, so that's why the unit will be meter, so in the direction of the force. So this is the answer. So here is a question. It is given that the body's mass is 8 kilogram and acceleration is 4 meter per second square in upward direction, and the requirement is find the value of P. So M is given, and 4 meter per second square acceleration is given. So we will find the resultant force. So the formula used will be F is equal to MA. So F is the requirement, M is 8 kg, and A is 4. So 8 fours are 32 Newton is the force. That will be the resultant force. So remember one thing, when more than one forces are applying on the body, so the resultant force will produce the acceleration. So if this is resultant force, so this means that P will be equal to 32, because this is the resultant force, plus 6, because 6 Newton will be balanced out with each other. So actually 38 Newton is P. Here is another question, and the statement of the question is, if the mass of 3 kg is there and a few forces are acting on the body, find the magnitude of the acceleration and the direction of the acceleration. So acceleration is the requirement. So look now, downward forces are 16 Newton in total. That will be balanced out with the upward forces, because upward force is also 16 Newton, downward forces are also 16 Newton. So these will be cancelled out with each other. There will be no acceleration in the vertical direction. But on the horizontal side, if you can see, towards right side, there are two forces acting. This is towards right, and this is also towards right. So towards right, we are having two forces that will make 30 Newton in total. But towards left, there is only 10 Newton force. So the resultant force will be towards right. That will be 20 Newton. Because this 10 Newton and 10 Newton are in opposite direction, these will cancel out each other. So this is the force that will move the body. So the resultant force is 20. So look now, here is the solution. F is equal to 20 Newton. M is 3 kg. And A is the requirement. So the formula will be used. F is equal to MA. F is 20, M is 3, and A is the requirement. So A will be equal to 20 by 3. So solving it on the calculator, because this is improper fraction. So 20 by 3. Answer is 6.67. So 6.67 meter per second square is the answer. But it is also required in which direction. So it will be towards right. So towards right, horizontally. So this is the full answer now. Here is another question. So look now, here is a body that is given, and many forces are acting on it, and the requirement is find M and P. Here is the P force that is acting towards left, and the mass of the body is required. Acceleration that is producing in the body is 2 meter per second square in upward direction. So first we will find the M. Okay, first we will find the resultant force, that is P force. So look now, in the upward direction, so because the acceleration is produced in the upward direction, so it means horizontal forces will cancel out each other. So if towards right there are 40 Newton force in total is acting, so P will also be 40 Newton to cancel out horizontal effects. So P will be equal to 40 Newton because the acceleration produced is in the upward direction. So it means there will be no resultant force in the horizontal. Okay, now come to the vertical components. In downward, there is 20 Newton forces acting, and in upward, there is 40 Newton forces acting. So it means 20 Newton force will be cancelled out with 20 Newton force, and 20 Newton force will be left as a resultant force, which will move the body in upward direction. So resultant force is 20 Newton. Acceleration produced is 2 meter per second square. And requirement is now m. So formula will be used, F is equal to ma. So putting values into the formula, so F is 20, m is the requirement, and a is 2. And from here 2 will come to the denominator here, so m is equal to 10 kg. So m is 10 and P is 40. So this is the answer. Here are some questions which we are going to do. A block of the mass 6 kg is pulled along a smooth horizontal surface. So mass is given, that is 6 kg. So it means M is equal to 6 kg. By a horizontal string, if the block reaches a speed of 20 meter per second in 4 seconds from rest. So from rest, it means initial velocity will be 0. And this is the final velocity, that is 20 meter per second. So final velocity is v, so v is 20 meter per second, and initial velocity is 0, that is u is equal to 0, and time is 4 seconds. Find the tension in this string. So it means F, force is required. So this is the data. M is 6 kg, v is 20 meter per second, u is 0, time is 4 seconds, and F is required. So come to the board now, we will solve it now. So here is the data of question number 10. M is 6 kg, U 0, V 20 meter per second, and time is 4 seconds, and F is the requirement. So first we will find A by using the first equation of the motion, that is V is equal to U plus AT. So this is the first equation of the motion that will be used to find A according to data. Now we are going to put these values into the formula. So look now, V is 20, U is 0, A is required, and time is 4 seconds. So from here, this 4 will come to the denominator of 20. So A will be equal to 5 meter per second square. So this is the unit for acceleration. And now we will find F by using the formula. F is equal to ma. Now m is 6 kg and A is 5. So 6 5s are 30. And because this is the force, so unit will be Newton. Here is question number 11. The statement is a constant force of 80 Newton. So F is 80 Newton, X for 7 seconds. So T is 7 seconds on a body initially at rest. So it means initial velocity that is represented by U. So U is equal to 0, giving it a velocity of 35 meter per second. So it means final velocity, that is V. So V is 35 meter per second. Find the mass of the body. So M is the requirement. So this is the data. So come to the board now. We will solve it on the board. So here is the data of question number 11. F is 80 Newton, time is 7 seconds, initial velocity is 0, final velocity is 35 meter per second, and M is the requirement. So again, first we will use these values to find the value of A. So here is the first equation of motion that will be used. So V is equal to U plus AT. Now U is 0 and V is 35. So 35 is equal to 0 plus A, and time is 7 seconds. So from here, this 7 will come to the denominator of 35. So A will be equal to 5 meter per second square. Now we are going to find M. Here is F. So formula will be used. F is equal to MA. So F is 80 and M is the requirement and A is 5. So this 5 will come to the denominator of 80 will be equal to M now, and 5 ones are 5 and 5 6 are 30. So M is equal to 16. Unit of the M will be kg. So this is the answer. Here is question number 12. The statement is a force of 12 Newton. So F is 12 Newton, X on a particle of mass 60 kg. So M is 60 kg, causing the velocity of the particle to increase from 3 meter per second to 7 meter per second. So it means this is the initial velocity, that is U is equal to 3 meter per second, and final velocity is V, that is 7 meter per second. So U is 3 and V is 7 meter per second. Find the distance. So S is the requirement that a particle travels during the particle. So look again, the data is F 12 Newton, mass M is 60 kg. So U is 3 meter per second and V is 7 meter per second, and S is the requirement. So this is the data. Now come to the board. We will solve it on the board now. So here is the data of question number 12. F is 12 Newton, M is 60 kg, initial velocity U is 3 meter per second, final velocity V is 7 meter per second, and S is the requirement. So first we will find A by using these two values. So look, now here is the solution. So F is equal to MA, F is 12 and M is 60 and A is the requirement. So from here you can see 60 will come to the denominator of 12. So A will be equal to 1 by 5 meter per second square. And now we will solve the rest of the things. So S is the requirement and A is here now. So third equation of the motion will be used, that is 2AS is equal to V square minus U square. Now putting values into the formula, A is 1 by 5, S is the requirement, V is 7, so 7 square will be 49, minus U is 3, so 3 square is 9. So from here solving it, so 49 minus 9 will be 40. This 5 will be multiplied by 40 and this 2 will come to the denominator. So 2 20s are and 25s are 100. So S will be equal to 100, and this is because distance. So unit will be meters, because meter is the unit that is used in the question. Here is question number 13. The statement of the question is a body of the mass 120 kg is moving in a straight line at 8 meter per second. So the data is M is 120 kg in a straight line at this, when the force of this acts in the direction of the motion for 18 seconds. So what is the speed of the body at the end of the time? So it means final velocity V is the requirement, U is 8 meter per second, F is 40 Newton and time is 18 seconds. So the data is F 120 kg, U 8 meter per second, F is 40 Newton, T is 18 second, and V is equal to question mark. V is the requirement. So this is the data. So now come to the board. We will solve it on the board now. So here is the data of question number 13, that is mass M is equal to 120 kg, initial velocity is U, that is 8 meter per second, force is 40 Newton and time T is 18 second and final velocity is the requirement. So look now, first we will find acceleration by using these two values. So F is equal to MA. F is 40, mass is 120, and A is the requirement. So from here, this 120 will come to the denominator over here. So A will be equal to 1 by 3 meter per second square. Okay, now we are going to find the V by using the first equation of motion, that is V is equal to U plus AT. So V is the requirement and U is the initial velocity, that is 8 given, plus A is 1 by 3, and the time T is 18 seconds. So 3 6 are 18 and 8 plus 6 is 14. And because this is the velocity, so the unit will be meter per second.